when we read this problem, there's some key words. The product of a negative integer, x, and a number 5 more than x is at most 50. The first key word here is product. Hopefully you know that product means multiply. So it's saying multiply two things, and what's the answer? Next, you see the word negative integer. Hopefully you know what negative means. It's pretty easy for most. But integer, some people don't know the definition of integer, and that's really important here. Later in this problem, this word integer is really important. An integer is a positive or negative whole number. Let me write that in real quick. Integer, and you might want to write this in, it's a positive or negative whole number. That is what an integer is. Positive or negative whole number. If you don't, it will mess you up later, you'll see, if you don't know that. So the product of a negative integer and a number 5 more than x, do you understand more, is that plus or minus? That could be plus going on. And then at most 50, at most is that greater than or less than. You'll see that in a second. So what we're going to do here is create an inequality and then solve it. And then think about the inequality in context. That's what this is kind of going to be about. So let's create an inequality. We're looking for the product of a negative integer x and a number 5 more than that. So let's start with that. How would you write a product of x and a number 5 more than that? Well, hopefully you can kind of think of, okay, the number x times a number 5 more than it. So what would 5 more than x be? Well, isn't it x plus 5? Now some people might wonder, but it says negative integer. Don't worry about it. Can x be a negative integer? Yeah, so just put x. Don't worry about putting negative x. Just put x. Don't put a negative x because the negative integer will be taken care of in the end. So don't worry about the negative at this point. Just think of a value times something 5 more than it. Then it says at most 50. So at most 50. So is that going to be a less than or a greater than 50? If I say at most, is 50 the highest or the lowest? When I say at most 50, won't 50 be the highest amount? So to be the highest amount, won't that be a less than? Oh, wait, isn't it less than or equal to? If I say at most 50, is 50 okay? Yeah. So is that the product of two numbers, 1 5 more than it, is at most 50. All right. So we created an inequality. Now we're going to solve it. Now to solve this, it says right here, solve it, you got to choose the right way to solve this. Now you hopefully notice this is a quadratic. Now if that was a 0 here, would your answer just be 0 and negative 5? With some other stuff with this inequality. But that's not a 0. So the first step we're going to do to solve this is do a distributive property. And I got x squared plus 5x is less than or equal to 50. Alright, so I now got it like this. Now we got to decide out of these, now we can easily see it's a quadratic. We got to choose which method. Now right off the bat you can hopefully see, why is square rooting like a really poor choice? Actually some possibility choice. Well, isn't there an x squared and an x? And square rooting does not work when there's an x squared and an x. So we know we're not going to be square rooting to solve. How about completing the square? Kind of set up for completing the square, but how many want to take 5 and divide by 2, get 2.5? Square 2.5, not a good choice. Can you see why completing the square not a good choice? Okay, so we got quadratic formula and factoring. If it was me, I would try factoring first. So let's just try it out. And in order to factor, don't you even have to make a 0 here? So how do you get rid of the 50? Just minus it over. So let's minus that 50 over, minus the 50 over. We now have x squared plus 5x minus 50 is less than or equal to 0. All right, now we got it to here. And we talked about factoring. It's probably the best choice over quadratic formula, at least to try to start off with. So let's factor this. I have negative 50 on top, and I have 5 on bottom. What two numbers multiply to get negative 50 and add to get 5? We know it's 10 and 5. Which one's the negative, though?
5.
To be a positive 5, the negative 5 right there. So it factors nicely. It's kind of nice. Yay, no quadratic formula. Now, we factored it. Now we got to kind of solve it. To finish solving this, I want to act like this is an equal sign. Right? If that was an equal sign, what are my two answers here? Think of it, what are my two zeros if this is a graph? What would make this 0? Would that be negative 10? What would make this 0? Positive 5? So can we just simply put my two answers are negative 10 and 5? So is that my answer, negative 10 and 5? Are we done? No, now we have to consider the inequality. In order to finalize this problem, I'm going to sketch this blue equation right here as if we're trying to graph this right here. We're going to graph that and see where the graph is below 0. You'll see it as I draw it here. I'm going to graph this original standard form equation. I want to know where it's below 0. So we'll start off with a quick sketch. And are we okay, according to our answers, don't we have negative 10 and 5? Are you okay? Those are two zeros. Hopefully you're okay. If this is the equation, the graph, aren't these two the zeros of my graph? And then look at it. Isn't that a positive a value? So will my parabola be happy, smile? If that was a negative, wouldn't it be upside down? So watch. If I draw a happy parabola through that, I don't care exactly how it looks, but as long as I draw that, are you okay? That's kind of what the graph would look like. The graph of this right here would look something like this, if you had a y right there. Okay, assuming that's a y right here, and assuming that's an equal sign, here's what we got. Now we have to do is analyze this graph, and it's just pay attention closely. What we're going to do is we look at this. Isn't this the blue parabola right here? Okay, that parabola graph is less than 0. So looking at this graph, where is the graph less than 0? Now instead of less than or equal to, we'll come back to that. Isn't less than or equal to mean below? When is this graph below 0? Now, do you guys understand there's three intervals here? Isn't there an interval here, then an interval between the dot, and then an interval from here to the right? So let's start over here. Just put your pencil down right on that line. Okay? I mean, point it, not like lay it down. But put your pencil, point to it right there. Now, in this interval where I'm pointing, is my parabola below the 0? Are you okay by the way, are you okay this is your 0? The x-axis is your 0? So at this point, is that blue graph below where I'm pointing? No, isn't it above it? Okay, let's go in between these two dots. Let's touch the line, the x-axis. Let's just touch it right here. Now, is my blue graph below that point? Oh, it is. So what I'm going to do here is realize, okay, that's part of my answer right there. Any value in between those works. Because in between negative 10 and 5, isn't your graph below 0? Your graph is below 0. If I touch out here, is your graph below 0? No, it's above. So are we okay? My answers are right here in between. How do we write that as an answer, though? Here's how you write it. We write it as from negative 10 x to 5. So that's saying right there, that is an ugly looking less than or equal to. And that's not an S, it's a 5. My beautiful handwriting. So we're saying from negative 10 to 5 are my answers. X's value anywhere between there. And do you see why I have or equal to? Because aren't the edges included according to the problem? That's how you write it. You don't write in the interval notation. I like this notation for these answers. This is saying from negative 10 to 5, x is between that, including the edges. Now we just did this problem, but what if it was a greater than? What if this problem, this equation, instead of a less than or equal to, what if that was a greater than? So this is not part of the problem. Let's just think about it. We're going to add a little if then, if statement. If it was a greater than, what would your answer look like? Well, could you tell it's the outside of the parabola? Could you tell it would be over here and here? Got that? Wouldn't it be the outsides? Isn't this where it's above? Isn't this where it's above, greater than, above? So my answer would look like this. It would be x is less than negative 10, or x is greater than 5. Now, the reason it's not or equal to is it's a greater than, not greater than or equal to. So you don't include negative 10 and 5, they're just edges. But it'd be to the left of negative 10 and to the right of 5. That's only if, and on the benchmark they can switch on you, so be careful. It could be a greater than or less than depending how you set it up. So you might want to add this as a, what if that was the situation? It isn't for this one, but what if? So, what are all the possible integers for x? And then why are some not viable is the second part. Well, if you look at this answer and you look at this sentence, the product of a negative integer x is a negative integer. Are all these negative integers? No. I have some positives. Right here, see right here? And what would negative 3.6 be okay? No, that's not an integer. That's a number, negative number. Oh, so my possible answers are part of this. This is just my basic solving. Now we got to look at this carefully and see what are my actual answers for the problem we have in front of us. So here's how I want you to write your answers. You want to write it in this kind of set notation thing. We're going to start with negative 10. I'm going to put negative 9. Now could I go all the way to negative 1? Is 0 going to count? 0 is not a negative integer. It's not negative. So when I go from negative 10 to negative 1, is that kind of a lot of numbers? Here's how you can kind of do it shorter. I'm okay with this. Can I put dot, dot, dot? You guys seen that before? And then go from negative 2 to negative 1. Now, you could write all of them out. Go negative 10 all the way to negative 1. Have fun. Or you can write it like this. These are saying only integers, only these values, not anything in between them. So, next is, why are some of the solutions not viable? Instead of saying what's not, let's just say, why are these the only solutions? Why are these what we're choosing? And the two key words that I'd be looking for, and that like a computer, if it was grading, it would be looking for, is probably negative integer. Those two key words should be somewhere. Because isn't that all what's based on? Aren't these all negative integers? Do you see there's no positives? And they're integers. They're not whole numbers. So somehow in it you should be talking about negative integers, or if you're saying nots, it should be positive whole numbers aren't working, or positive non-whole numbers. It'd be confusing. So let's just call it some sentence dealing with I need them to only be negative integers. And that's all you have to say. Must be negative integers only. It must be negative integers only. That's an okay statement. You cannot have positive, you cannot have decimals, but that, I'm saying if I only want negative integers, that is an explanation. Now, what if it was not a negative integer? What if it was positive number? So here's another what if. Put a little box right here, I'm doing my little what if. What if it was positive number? Instead of negative integer, what's a positive number? Well, your answer, if it said positive number, would be values from 0 to 5. Aren't those my positive numbers? And doesn't that notation include decimals? See this? This doesn't include decimals. I'm writing out each number one by one. This includes decimals, includes fractions, includes anything in between. Now, why did I not put a line underneath 0? Is 0 positive? No, it's neither positive nor negative. So do you see why I didn't put a line underneath that? Where 5, is 5 included? Yeah. So So with this right here is saying negative 8.6. That counts it. No, not negative. Sorry. Negative doesn't work. But if I had 3.5, would that be in here? 7.2? Nope, out of it. But any decimals included in this notation. If it's integers, you need to write your integers as 1 by 1.